During World War II, over 1 million vehicles ran without gasoline. They burned wood, not converted to ethanol, not processed into biodiesel. Raw wood, fed into a steel chamber, turned into engine fuel. The technology worked so well that entire countries ran on it for 6 years. In 1989, the United States government published complete construction blueprints through the Federal Emergency Management Agency. Then, the Environmental Protection Agency made it illegal to use on any public road in America. Right now, Americans pay $4 to $5 a gallon for gasoline. That gasoline comes from a supply chain that can collapse overnight. One pipeline shutdown, one refinery fire, one embargo, and your vehicle becomes a 2-ton paperweight. The system we're talking about today runs on fallen branches and scrap lumber. The fuel cost is $0, not low, zero. By the end of this video, you'll understand exactly how the system works, why it was buried under regulation, and how to build one yourself. Welcome back. If you're new here, this is what we do. We dig up practical knowledge that's been buried, suppressed, or simply forgotten. Not fear, not panic. Verified, actionable information that puts capability back in your hands. If that sounds like something worth protecting, subscribe now. Because this kind of knowledge doesn't survive unless people pass it on. This community values self-reliance and verified facts over speculation. Everything we present, you can check for yourself. The sources are real. The documents are public. Let's start with the science, because once you understand the mechanism, the history makes perfect sense. The process is called wood gasification. It is not burning wood to make heat. It is burning wood under restricted oxygen to produce a flammable gas. That gas is called synthesis gas, or syngas, and it can run an internal combustion engine. Here's how it works. A gasifier is a sealed steel chamber. Wood goes in at the top, gas comes out through a pipe. Inside that chamber, 4 distinct thermal zones do the work. The first zone is drying. Wood enters and encounters rising heat. Moisture boils off. The wood needs to be below 20% moisture content before it enters the system, and this zone finishes the job. The second zone is pyrolysis. Temperatures reach 400 to 600 degrees Celsius. The wood breaks apart, not through burning, through thermal decomposition. Volatile compounds release as gas, charcoal forms. Tar vapor rises. The third zone is combustion. This is the hottest point, 900 to 1200 degrees Celsius. A small amount of air is injected through nozzles called tailleries. The charcoal ignites. This zone provides all the heat that drives every other reaction in the system. The fourth zone is reduction. Hot combustion gases pass over a bed of glowing charcoal. Carbon dioxide meets carbon and becomes carbon monoxide. Water vapor meets carbon and becomes hydrogen gas. This is where fuel is born. The output is syngas, a mixture of carbon monoxide, hydrogen, methane, and nitrogen. Now, syngas is not as energy dense as gasoline. It contains roughly 1/3 the energy content per unit volume. That means an engine running on wood gas loses 30 to 50% of its power compared to gasoline. That is a real limitation. We will address it honestly later, but it runs. It produces mechanical work. It moves vehicles. And we know this because over 1 million vehicles proved it across an entire continent for 6 years. When petroleum supplies were cut off during World War II, Europe did not stop moving. It adapted. Sweden converted over 70,000 vehicles to wood gas by 1945. Germany operated an estimated 500,000 gasifier-equipped vehicles at peak deployment. France, Finland, Denmark, and Norway all ran substantial wood gas fleets. These were not experiments. These were factory-manufactured systems. Companies like Imbert in Germany, SFIA in France, and Pinch produced standardized gasifier units. Refueling stations stocked pre-cut wood billets in standard sizes. National transportation networks, civilian and military, ran on this technology for the duration of the war. Trucks, buses, tractors, passenger cars, boats, stationary generators, all running on wood, over 1 million vehicles. 6 years of continuous, validated daily operation. So if it worked for 1 million vehicles across an entire continent for 6 years, why have you never heard of it? What we've covered so far is the surface. Behind this video is a full research file containing construction diagrams, performance tables, maintenance schedules, filtration system specifications, and a complete legal analysis of the regulatory framework. The vault link is in the description. No fluff, no filler, just the complete documentation. But stay right here, because what comes next is the part that should genuinely concern you. In 1989, the Federal Emergency Management Agency published a document designated FEMA P23. It was prepared by the Biomass Energy Foundation with technical support from Oak Ridge National Laboratory. The title is straightforward. It contains complete construction drawings for a stratified downdraft gasifier, materials lists, operational instructions, performance specifications for engines up to 25 to 30 horsepower. The document was not theoretical. It was explicitly designed for emergency scenarios. The publication lists its intended use cases clearly: petroleum embargo, infrastructure collapse, nuclear war. Situations where gasoline no longer exists and people still need to move, generate power, and survive. The United States federal government validated wood gasification. It hired a national laboratory to design an optimized unit. It published the blueprints. It told citizens exactly how to build one. Now here is where the contradiction becomes impossible to ignore. The Clean Air Act was passed in 1970. It was amended in 1977 and again in 1990. Title 40 of the Code of Federal Regulations, Part 86, establishes emissions standards for motor vehicles. Every vehicle operated on public roads must meet those standards. Raw syngas contains 18 to 22% carbon monoxide by volume. After combustion in an engine, the exhaust produces carbon monoxide levels 10 to 20 times higher than a modern gasoline engine equipped with a catalytic converter. No gasifier system can meet those thresholds. No manufacturer can certify a wood gas vehicle. No individual can register one for road use. The emissions gap is not close. It is orders of magnitude beyond compliance. And here is the detail that should stop you cold. There is no emergency exemption. The Clean Air Act contains no provision for suspending emissions standards during a petroleum emergency. The FEMA blueprints assume a scenario where regulatory enforcement has ceased. That is an implicit admission. The government published survival technology that its own laws prohibit you from using, and it built no legal bridge between the two. Search the Red Cross emergency preparedness guides. Not there. Search the Department of Energy resilience publications. Not there. Search the Department of Homeland Security continuity planning documents. Not there. Search agricultural extension curricula across all 50 states. Not there. A technology proven by over 1 million vehicles, validated and published by a federal agency, does not appear in a single mainstream emergency preparedness resource in the United States. Now ask yourself, who benefits from keeping this invisible? The global petroleum industry generates trillions of dollars in annual revenue. Gasoline costs $4 to $5 per gallon at the pump. A wood gasifier runs on foraged material, fallen branches, scrap lumber, storm debris, sawmill waste. The fuel cost per mile is $0. Most alternative fuels do not truly threaten the petroleum model. Ethanol requires purchased corn or sugarcane in industrial processing. Biodiesel requires purchased oils and chemical conversion. Both still run through a supply chain. Both still cost money per gallon. Both can be taxed, metered, and distributed through centralized infrastructure. Wood gasification is different. It is the only alternative fuel system that eliminates the fuel purchase entirely. There is no feedstock to buy, no refinery to process it, no pipeline to transport it, no retailer to sell it. A person with a welder and access to a woodlot can produce their own engine fuel indefinitely. 20 to 30 pounds of dry wood per hour will sustain a 25 horsepower engine. 100 pounds of wood moves a vehicle 15 to 25 miles. You cannot patent wood. You cannot trademark fire. You cannot meter foraged branches. You cannot build a recurring revenue model on a fuel source that falls from trees. And in a multi-trillion-dollar industry built entirely on selling fuel, that is not an inconvenience. That is an existential threat to the business model. After the war ended, petroleum was cheap and abundant. The gasifier fleets disappeared within months. Oil companies invested billions in infrastructure, marketing, and political influence. The internal combustion engine became permanently married to the gasoline pump. And a technology that kept a continent moving for 6 years was simply never mentioned again. If you're still here, you're exactly the kind of person this channel exists for. This is the kind of knowledge that disappears if nobody passes it on. Hit subscribe. Share this with someone who needs to see it. The full build overview is next. Before we get to construction, I owe you the honest truth about what this system cannot do and what it can do to you if you're careless. Carbon monoxide poisoning. Syngas is approximately 20% carbon monoxide. It is colorless, it is odorless, it is lethal. During World War II, fatalities from carbon monoxide exposure were documented. A gasifier must never be operated in an enclosed space. Carbon monoxide detectors are not optional, they are mandatory. Fire and explosion. Syngas is flammable. The combustion zone inside the gasifier exceeds 1,000 degrees Celsius. Leaks at pipe joints can ignite. The system must be constructed with welded or threaded connections. No shortcuts. Tar fouling. Incomplete gasification produces tar. Tar clogs filters, coats engine valves, and gums intake manifolds. A well-designed downdraft gasifier minimizes tar, but regular cleaning is non-negotiable. Engine wear. Waste fine ash particles pass through filtration and accelerate wear on piston rings and cylinder walls. Engine life is reduced compared to gasoline operation. Filtration quality directly determines how fast this happens. Power loss. 30 to 50% reduction compared to gasoline. This is inherent to the lower energy density of syngas. A vehicle that produces 100 horsepower on gasoline will produce 50 to 70 horsepower on wood gas. Fuel preparation. Wood must be cut to 1 to 3 inch chunks. It must be dried below 20% moisture content. This takes labor and time. You are trading money for work, legal risk. Operating a wood gas vehicle on public roads violates federal emission standards, period. These are real constraints. None of them are trivial. But in a scenario where gasoline does not exist, every single one of these trade-offs becomes acceptable compared to the alternative, which is not moving at all. Here is what you need to build a functional gasifier based on the FEMA P23 stratified downdraft design. The outer shell is approximately 20 inches in diameter and 40 inches tall. You can fabricate this from a steel drum, heavy steel pipe, or stacked galvanized containers welded together. The material must withstand sustained heat without structural failure. Inside the outer shell, mount an inner fire tube concentrically. This tube is approximately 8 inches in diameter. This is where gasification occurs. The space between the inner tube and outer shell acts as a preheating jacket for incoming air. At the bottom of the fire tube, install a steel bar grate. This supports the charcoal bed and allows ash to fall through for removal. Above the grate, install tuyères. These are air injection nozzles made from 1/2 inch to 3/4 inch black iron pipe nipples. They protrude through the wall of the fire tube and direct air into the combustion zone. The number and angle of these nozzles determine combustion efficiency. At the top of the outer shell, weld a 2-inch gas outlet pipe. This is where syngas exits the system. The raw gas exits at over 300 degrees Celsius. It must be cooled before it reaches the engine. Run the gas through a length of radiator tubing or water-jacketed pipe to bring the temperature down. After cooling, the gas must be filtered. First, route it through a cyclone separator to remove large particulates. Then, pass it through a packed media filter using wood shavings, gravel, or combination. Finally, run it through a fabric filter for fine particles. The cleaned gas connects to the engine intake through a mixing valve. This valve allows you to adjust the ratio of air to syngas for optimal combustion. A butterfly valve or gate valve works. To operate, load charcoal at the bottom of the fire tube as a starter bed. Fill the remainder with dry hardwood chunks, 1 to 3 inches, below 20% moisture. Ignite the charcoal through the tuyere openings. Allow 5 to 10 minutes for the combustion zone to establish and for quality syngas to begin flowing. Start the engine on gasoline or propane. Once running, gradually close the gasoline supply and open the syngas valve. The engine will transition to wood gas. You will hear a change in engine note. This is normal. Adjust the air-to-gas ratio until the engine runs smoothly. Refuel with wood every 30 to 60 minutes depending on load. Clean the ash grate and check filters regularly. Cold starts require gasoline or propane. Hot restarts can run on wood gas alone. The total cost for materials, if you're scrounging from scrap yards and hardware stores, is typically between $75 and $200. Now you know what they knew in 1945, what they published in 1989, and what they made illegal for you to use on your own road. Over 1 million vehicles ran on this technology for 6 years across an entire continent. The United States government hired Oak Ridge National Laboratory to design an optimized version and published the complete blueprints through FEMA. Then, the EPA set emission standards that make it impossible to operate legally, and included no exemption for the very emergencies that justified publishing the plans in the first place. The knowledge exists, the blueprints are public, the materials are in every hardware store and scrapyard in the country. The science is textbook thermochemistry. The history is documented beyond any reasonable dispute. The fuel falls from trees. The only barrier is awareness. And now you're past it. Someone you know needs to see this video. Someone who takes preparedness seriously. Someone who understands that supply chains are fragile and that real resilience means real capability. It's not just stored food and water. Share this. Next week, we open the vault on another technology that the preparedness community has almost completely overlooked. You will not want to miss it. Subscribe now so you don't.